and we've got quite a good build up of program for from March onwards, and we're looking at in March potentially doing our first face-to-face, but I'll keep you updated with that. Okay, so next. So as I said before, any questions, please put them in the chat function, and then we'll ask the speaker later on after his talk. So today's discussions on machinery safety from Jason Reed at Pilt's Automation Technology Limited. So I will stop sharing now and pass it over to Jason. Okay. All ready to go, Jason?
Okay, yeah, good evening, everybody. Hopefully you can all hear me loud and clear. As Richard said, my name is Jason Reed. I'm one of the account managers at Pilt's Automation, based in Corby in the Midlands. And I've been asked this evening to do a presentation on machinery safety, which, as you can imagine, is quite a large topic. So we'll basically do a snippet, really. So the agenda for the presentation will be an introduction to the legislative framework and directives or regulations as they are now. We'll look at the standards, directives for OEMs and end users. We'll go into Pure. We'll look at CE/UKCA marking, what is an assembly of machines, and then we'll touch briefly on ISO 13849, which is safely rated parts of the control system. We'll go into categories, fault masking, and then I'll do a little sales pitch at the end. So there'll be an overview on Pilt's as a company and what we can provide. So if I go into standards and directives for OEMs and operators, really for plant and machinery, they can be split into two. So we have what was the machinery directive or the supply of machinery safety regulations, which is for the equipment manufacturer, the OEM, typically. And then we have for end users or the operator, we have what was UED, which is the provision and use of work equipment regulations, Pure, which is a user directive. Although as an end user, you can also become an OEM, and we'll run through that on a few more slides time. So just to give an idea of standards, an overview of standards, it is a legal requirement to follow the supply machinery safety regulations. It isn't a legal requirement to follow a standard. However, if you follow the standard and the process of that standard, it's easier to show conformance to supply machinery safety regulations, as opposed to making up your kind of own policies and procedures, really. So standards are broken into three. We have A, B, and C standards. A, of which there's only really one, which is ISO 12100, which is risk reduction and design principles. We have B standards, of which there's two types. There's B1, which are general safety aspects, and that could be 13857 for safety distances, 13849 for safety control systems. And then you have B2 standards, which are specific to protective devices. So in that case, that could be 14119 for interlocks or 13850 for emergency stops. And then finally, we have C-type standards, which are special safety features for individual machine groups. So for instance, you've got 14115 for packaging machines, 201 for injection molding machines. So if you were a manufacturer of packaging machines, you'd have a look at 415 part 1. Have a look at what type of packaging machine you manufacture, and then that would tell you which part of the standard you would need to follow. And if you followed it from the letter of the law in sequence, then you can claim conformance against the supply machinery safety regulations against that C standard. The thing to bear in mind is that A and B and C standards are very rarely updated. Typically, B standards are updated on a more frequent basis due to technology changing, etc. And so what you have to be mindful of is that though there could be a C standard for your particular machine as a manufacturer, it could very well be out of date. And so therefore you'd need to go back and check the relevant A and B standards as well. Excuse me. So use of work equipment directive. The employer should take the necessary measures to ensure that work equipment made available to workers is suitable for the work without impairment to their safety or health. And it was adopted into UK law as the provision of use of work equipment regulations, or PUR 98. And so what happened pre-Brexit really is that Brussels would create the directives, and then it would be up to each individual member state to transpose that into their own national law. And so for the UK, we took UWED and turned that into PUR. So the key factors are to comply are requirements on control and electrical systems, protection against dangerous machinery parts, conditions of work equipment, training of workers, and written safety instructions. And you can see on the picture, you can download the ACOP from the HSE website. So PUR requires that all equipment and machinery is safe. So if you were to have an incident, typically what would happen if HSE would come in to inspect, then they would typically ask for your PUR documentation, your inspections. If you don't have them, then you would have been basically breaking the law because you haven't carried out a PUR inspection. But also if you have that inspection, they'd most likely prosecute you under it because PUR requires that the equipment is safe. And the fact that you've had an incident or an accident, they would prosecute you because they'd say that you had a failing against it. But under PUR, you should make sure that the equipment is suitable for the intended use. It's safe for use, maintained in a safe condition, and it's inspected to ensure it's correctly installed and does not subsequently deteriorate. It's used only by people who have received adequate information, instruction and training, and accompanied by suitable health and safety measures, so such as protective devices and controls, and that could include emergency stops, adequate means of isolation from sources of energy. You've got clearly visible markings and warning devices. So PUR is made up of 37 regulations that are broken down into 6 sections. Section 1 deals with interpretation. So what is the work equipment? What is it used for? Section 2, which are regulations 4 to 10, that's the management issues with regards to ensuring the suitability of the work equipment for the job it has to do. So you're looking at maintenance, routine maintenance, planned maintenance issues, training of all staff. Have you got a training matrix? And ensuring that staff are aware of the risks to their health and safety when using that piece of work equipment. Section 3 is a physical examination of the machine. And so here we're looking at regulations 11 to 24. So 11 is dangerous parts of the machine, 12, protection against specific hazards. Regulation 13 is high or very low temperatures. 14, controls for starting or making a significant change in the operating conditions. Regulation 15 is stop controls. 16, emergency stop controls. And it's worth bearing in mind that emergency stop controls shall have priority over any control provided for the work equipment under Regulation 15. So it should, e-stop should take priority. 17 is for controls, 18 control systems, 19 isolation from sources of energy, which doesn't just mean electrical. Regulation 20 is stability, 21 lighting, 22 is maintenance operations, you have 23 for marking, and finally 24 for warnings. So that's where you have to have some kind of, that's where you have to be competent, really. So anybody can carry out a pure assessment, but they should be competent. Regulations 25 to 30 are specific to mobile work equipment, and 31 to 35 are specific to power presses, and 36 and 37 cover exemptions. Firearms, for instance, by nature, a firearm is dangerous. In fact, it's going to cause potentially loss of life, so exempt. But if we look into one or two of the regulations in a bit more detail, Regulation 11, dangerous moving parts, measures must be taken to provide access to any dangerous part or to stop dangerous movement before any part of a person enters a danger zone. And these measures in hierarchical order consist of the provision of fixed guards, the provisions of other guards or protective devices, the provisions of jigs, holders, push sticks, or similar protection appliances, and the provisions of such information, instructions, training, and supervision as is necessary. And so to do this adequately, you would need working knowledge, and this is the competence really, of standards such as 14120, which would be designing and implementing guarding, 14119 for interlocking, 13857 for distances and sizing of guards, 13855 for safety distances, stopping times, etc. And all guards and protection devices shall not give rise to any increased risk to health and safety, not easily be bypassed or disabled, and be situated at sufficient distance from the danger zone, taking into account reach over, reach through, and stopping/run down times. And what we mean by that is, you can see on the image on the top right, we've got an interlock mounted on the guard with a tongue switch, and you can see that the fixings are no longer holding that tongue in position, and so therefore you can go into the machine and the machine would still be operating. You can see the picture underneath is of a two-hand control, and it looks like somebody's tie wrapped a bar so that you can actually now use it with one hand. And finally, you can see the very bottom picture here. We've got another interlock with a rocker switch on it that's been bypassed as somebody's put a cable tie over it. So as an OEM, you may very well have manufactured your machine with this type of interlock fitted to it due to costs and your interpretation of the standards. But as an end user, when you've come to carry out your pure assessment, you can very well see that you deem it not sufficient because it's easily bypassed or disabled, and so therefore you would look to change and modify it. So what are the current dilemmas at end user sites? So we typically see things ranging from insufficient guarding, so there may not be any guarding, too large a gap, might be damaged, the wrong size, distance, the fixings that are used, incorrect positions of light curtains and scanners. So on the previous slide, it may be that the light curtain is too far away from the actual hazard. And so if you were to break the light curtain beam, the hazard doesn't actually stop before your hand or body still gets to that hazard. And so the stop performance calculations haven't either been calculated correctly, or the machine may have been changed over the years and the light curtain hasn't been tested. Possible fault masking issues in guard safety switch circuits, and we'll run through that a bit later on. Open access into dangerous parts of the machinery. You might have uncontrolled access into the moving part of the machine. So there's actually no speed monitoring or monitoring of the machine rotating. You may have no safety when it comes to the pneumatic or the hydraulic controls. They're not safety rated. You may have old or non-existent pure assessments. So as discussed earlier, it is a legal requirement. Or new machinery arriving on site doesn't meet the current regulations. Or again, that may be that if you've got a sister site, be that in the UK or overseas, that when their machine comes to your site, though they've been using it, it might not meet the regulations. So the law, why must we risk assess? And I'm conscious of the audience that I'm presenting to. So the Health and Safety at Work Act under Section 2 requires employers to provide safe equipment to employees, and Section 3 and a safe environment for anyone else who could be affected. And the Management of Health and Safety at Work Regulations 1999, this is where the legal requirement to carry out a suitable and sufficient risk assessment to justify that the equipment is safe. And even if you purchase a CE/UKCA marked machine, you must conduct your own pure assessment and your own risk assessment. And the reason for that being that the machine manufacturer can't always anticipate where that machine is being installed, how it's being used, and by whom. And so an example of that may be that I supply you a machine with a hatch for you to carry out routine maintenance, perhaps to fill oil, for instance. But you've purchased that machine from me and you've mounted it in such a way that I can no longer get to that hatch because there's a piece of steel framework there, for instance. So, the manufacturer can't be held accountable to that because it's the way that you've positioned it as an end user, and that would be picked up under pure. So what is a risk assessment? So it's a documented physical examination and inspection of a machine, process or activity carried out under the guidelines of international and national standards. So the purpose of the risk assessment is to identify any hazards, estimate the risk, evaluate the risk, and then determine the risk reduction that may be applied to reduce the risk in accordance with applicable legislation, standards, and good engineering practice. So the risk assessment must be dynamic. So we must use a continuous process of identifying the hazards, assessing the risks, and taking action to eliminate or reduce that risk, and monitoring and reviewing. It must be a iterative process. So again, it must be ongoing as long as an acceptable risk is present. So we keep going around in a loop. And finally, it must be completed on a periodic basis. So what are the benefits of carrying out a risk assessment? We have a higher level of safety by identifying and addressing risks at an early stage. We have protection of employees from hazards in the workplace. We prevent accidents and injuries from mechanical, electrical, ergonomics. Protection of the employer from litigation. Cost savings, less downtime, for instance, on a machine. I've got to do investigation work, etc. Employee morale. And safety is a subject of quality. So, improved safety is improved quality. So by doing the risk assessment, we have to look at the machine limits. And so aspects to be considered when determining the limits of use are the machine's operating modes. So it could be, a normal operating mode under normal conditions. You might have another mode where you need to put it into a maintenance mode or a jog cycle, for instance. What are the possibilities of the user to intervene? The machine's area of application, the user's professional qualifications. Aspects to be considered when determining the space limits. So is there room to maneuver? The space requirements for people handling the machine, and the interaction between man and machine. Is there any crush hazards, for instance? And also aspects to be considered when determining the time limits. So the machine's lifetime, the operation, the maintenance, the disposal, It's okay putting the machine in, operating it, but how are you going to dispose of it when it comes to end of life? Can you do that safely? And the recommendation of maintenance intervals. So what are the types of machinery hazards? You have vibration, radiation, mechanical, electrical, thermal, ergonomic, noise, material and substances. All of these are different types of hazards that you'll find on machinery. So if we look at ISO 12100, safety of machinery, general principles for design, risk assessment and risk reduction, there is a chart in there that we can use for our risk assessment and risk reduction. And so we obviously start at the start. We look at the limits of the machinery, we identify the hazards, we look at the risk estimation and the risk evaluation, and then has the risk been adequately reduced? If it has, we can finish. If it hasn't, then we use a three-step approach. And the first step is inherently safe design measures. So they're protective measures which either eliminates the hazard or reduces the risk associated with the hazard by changing the design or operating characteristics of the machine without the use of guards or protective devices. So the first step is always looking at the design. So we may be using a load of rollers, for instance, on a conveyor. Could we use a belt instead? Would that reduce the risk? If we can't reduce the risk by inherently safe design, then we look at safeguarding, and they're protective measures using safeguards to protect persons from the hazards, which cannot be reasonably be eliminated, or the risk can't be reasonably eliminated from sufficiently reducing the inherently safe design. And finally, once we've done that, we have information for use. And that is where we use communication. So that would be warning signs, information for use, diagrams, etc., etc. Once we've done that, if there were any kind of protective measures that were dependent on a control system, then we'd have to use either 13849 or 62061, and I'll run through those in a bit more detail. And if no other hazards were generated, and we went through our process again, we're looking to see that the risk has been adequately reduced. If it has, then we can finish. If not, then this is where we have to go on our loop cycle and continue going through it until we get to an adequately reduced, the risk has been adequately reduced. So just a quick explanation on safeguards. So safeguard, if we look at guards, a guard may also be called casing, cover, screen, door, etc. But it's anything that acts as a physical barrier. Excuse me. And examples include enclosed fixed guards, self-closing guards, distance fixed guards, adjustable guards, interlocking guards, control guards, and the type of the material selected on application and risk assessment. So the picture you see on the top right, this is made of kind of like perspex. So it may be that you actually need to see what's going on within the machine. You need to see the process. And so it'd be crazy to make it out of mild steel, for instance, because you'd want to try and defeat that interlock because you'd want to see what's going on within it. And so from the risk assessment, we can determine that, and we'd select the appropriate material to suit. So the considerations for guards should not cause hazardous crushing or trapping points. Guards should be designed to offer adequate viewing, as discussed earlier. Demountable parts of fixed guards should only be removable with the aid of a tool. And if regularly removed, captive screws should be used. And what we mean by that is that you can see here that this guard has been removed a couple of times, and over that period of time, the screws have been misplaced, and so it's just been put back without any screw retaining it at all. And you'll typically find that on a lot of guards, really. And so now, if the guard is regularly removed, it should be captive, so that doesn't happen. And design and position so that during normal operation, they're prevented from closing with persons in the danger zone. We then have safeguarding products. So we've seen the actual guarding, but then products can range from mechanical interlock switches, magnetic safety switches, coded safety switches, magnetic interlocks, normally for process as opposed to safety, power to lock and unlock interlocks for guards, light curtain scanners, and more recently we're seeing a lot of radar protection as well. And then finally, yeah, so they're typically on the outside of the machine, but then also you've got safeguarding products that would be inside the panel itself. And so these are looking at the interlock, and then you've got the safety relays, controllers, and control systems that would evaluate the command of those interlocks, and then they would then send out a signal to stop the machine, or it may be to put it into a rundown mode, for instance. And then we have operated and monitoring, again, all safeguarding and to help aid with reducing motivation to defeat. So we've got e-stops, jog manual controls for jogging, pit mode for this is up for operating mode selection, and then you have signs, push button control units, etc. So if we put all this together as an example, this is a palletizer which would fall under 415 part 6. This is the palletizer itself. We've put a guard around it. We've tried to reduce it, the risk through inherently safe design. But what we've had to do then is use safeguards. So we've put a guard on here. We've got a light curtain. We've got e-stops. We've got interlocks. And so under normal conditions, the door would be locked. The light curtain is active. So you can't open the door and you can't gain access to the machine because you'd break the light curtain and it would stop the palletizer. So under normal conditions, the pallet would come along the conveyor. It would break the muting sensors of the light curtain so that it knows that it's a pallet and not a person. That would what we call mute the light curtain. So it would deactivate it. It would allow the pallet to pass while the light curtain is deactivated, and the pallet will actually be blocking the entrance. So the pallet itself actually becomes a guard. And then that would go into the machine would wrap it, and then it would go out. If the operator needed to do any kind of maintenance function, then they can come to the control panel. They could use RFID technology so that they can put that into the panel itself. They can select a mode of operations. They could tell the machine that they're a trained, authorized and competent maintenance engineer, and that would allow them to put the machine into, say, like a maintenance mode, bypass the switch, and by using a jog or two-hand pendant, they could then actually go inside the machine and actually either teach it or look at what the maintenance function needs to be. When they've finished, come out, close the door, and put it back into a run cycle. I'm conscious of time, so I'll skip on a little bit. So we then have the legislative framework, so regulations and standards really for CE and UKCA marking. So I'll touch briefly on CE marking. The machinery directive was introduced to ensure the free movement of goods into all member states, to ensure identical safety requirements for machinery in every country, to ensure a high level of safety. And as mentioned earlier, pre-Brexit, it was introduced into UK law under the supply machinery safety regulations, and post-Brexit, that still is what it remains. So in the UK now, and I'll exclude Northern Ireland, we have what is the UKCA mark. And so that was introduced from the 1st of January this year. And it was due, and so you had until the 1st of January 2022 to conform to UKCA marking and remove the CE mark. That's recently been amended, and so they've given another 12 months extension. So CE marking can continue for another 12 months. And so in the next few slides, you're going to see a mixture of UKCA and CE marking, really. What is worth pointing out is that if you are a UK manufacturer, if you're an OEM, and you are supplying into Europe as of the 16th of July this year, for it to meet the machinery directive, you would have needed somebody who resides within the European Economic Area to actually sign your declaration of conformity. So that is still something that's current. So who's responsible for UKCA marking or CE marking? So the responsibility for demonstrating that machinery satisfies the essential health and safety requirements of the applicable directives or regulations now can be UKCA marked, rests on the original equipment manufacturer or system integrator, agents that import machines, companies that directly import machines, persons who build machines for their own use, persons who substantially modify machines beyond their original specification. So it's worth bearing in mind that if you're an end user and you import a machine from China and it isn't UKCA marked or CE marked, then you actually take on responsibility of the manufacturer because you've imported the machine, and it would be your responsibility to CE mark it or UKCA mark it. So the process for using UKCA marking as opposed to CE marking, as you can see here, is pretty much identical. It's pretty much just the T's and C's that have changed, really. So you identify using UK regulations now as opposed to directives. We don't use harmonised standards, we use designated standards. And you would supply a UK declaration of conformity as opposed to an EC declaration. And you would place the UKCA mark as opposed to a CE mark. So it's worth pointing out that there is really no changes in the process of UKCA marking. So all the EHSRs, the essential health and safety requirements from the machinery directive, are still enshrined in the UK supply machinery safety regulations, and these are not changing currently. What it has changed is what was mentioned earlier, some of the phrases and the words. So directives, regulations, notified body is now an authorised body. And that's really why there's been the additional delay of 12 months to implement, because I think the majority of UK authorised bodies were inundated with projects from OEMs. And so to handle with the workload, it's been extended. Just some of the key directives and what they are now with regards to regulations. So machinery, supply machinery safety regulations. We've got, that should actually be 2000, I think that's an error, that should be 2008, not 2011. EMC is now electromagnetic compatibility regulations, 2016. So it's worth bearing these in mind, because if you're buying a machine from an OEM, when they supply with a declaration of conformity, on there will be the regulations that the machine meets. And so what you want to make sure is that they're actually current and not out of date. And, you know, if they are out of date or they're not correct, then, you know, that would raise cause of concerns as to what else could potentially be out of date and therefore doesn't meet the actual regulation. So it doesn't conform. Because if they're using an old directive or regulation, that could very well mean that they're using out-of-date standards as well. So I'll touch on assembly of machines, because this can be confusing to some end users and OEMs. So an assembly of machine consists of two or more machines or partly completed machines assembled together for a specific application. And they function as an integral whole and must achieve the same end. So they're all manufacturing the same widget, really. And the next three bullet points are the important part. So the constituent units are assembled together in order to carry out a common function. For example, the production of a given product. The constituent units are functionally linked in such a way that the operation of each unit directly affects the operation of other units or the assembly as a whole, so that a risk assessment is necessary for the whole assembly. And the constituent units have a common control system. All three of those must be met in order to meet an assembly of machines. So there can be no assembly of machines under the terms of the Machinery Directive or supply of machinery safety regulations when an overall complex has individual standalone machines or subsystems that are connected in terms of function and control, but not form a unit in terms of safety. Simple, right? So what do we mean by that? So, and it's worth bearing in mind really that when creating assembly of machines, certainly as an end user, you need to determine who is going to be responsible for that assembly and effectively UKCA mark it at the end. Is it going to be the OEM, an integrator, or is it going to be yourself? And that's something really that you would need to determine at the contractual stage, really, because if it isn't, then and you're just making assumptions, then the OEM or the integrator could at the end of the installation say, no, I've not quoted to UKCA market, and then that would then fall on your responsibility. So if we run through an assembly of machines, so a group of CE marked or UKCA marked machines that are physically connected to each other, but where each machine function independently of the others, and there's no common control system, is not considered an assembly of machines. And the reason for that is that they're all independent. Independent machine, independent, what we call PLC brain, and if this one stops, it doesn't affect any of the others. So here you can see an image here. An example of CE marked machines that are physically connected via a roll conveyors or chutes, but work independently and have an independent control system. Again, there's no overall CE mark that's required because the machine's all independent, but you've got kind of a gravity-fed conveyor that's going to feed the parts down. So if this stops, it has no bearing on the other two machines. The machines that are connected via power-driven conveyors but still work independently. So the conveyors have their own control systems based on sensors at the in and the out feed. So we've got our three machines again. They've got powered conveyors between each. And if this machine stops, then this machine's going to stop because it can sense that this machine's no longer working, for instance. It doesn't want to have a backup on the conveyor. So would that constitute an assembly of machines? Well, in most cases, the conveyors will have some kind of signal exchange for starting and stopping that you can see here. If that is the case, the third bullet point that was mentioned will be fulfilled, and CE marking is applicable if also bullet points 1 and 2 that were discussed were met. But in this actual case, it explicitly mentions that there's no signal exchange, and the conveyors and other machines are working as standalone units based on in and out feed sensors. And so in that case, the third bullet point, which is an overall control system, is not the case. And so therefore, this assembly of machines in this instance wouldn't need to be CE marked. And there's an example here. If we have an example of machines that are connected via robot conveyors or partly completed machine and work as an integrated whole, then this would need to be CE marked because we've got our three machines. We've got a robot, so it's a partly completed machine, and then we've got an overall line PLC. So it's looking at what each one is doing. And so that meets all three of the functions, the criteria. Likewise, the example here again is conveyors and robots or partly completed machines, but the signal exchange between each of the safety controllers is done via what's called a bus system. So again, all three criteria met, and you'd have to CE mark or UKCA mark the assembly as a whole. So the Machinery Directive and Supply Machinery Safety Regulation only covers new equipment. So we're in a kind of grey area when it comes to adding or replacing equipment. And there really is no clear criteria for this topic, but there is some guidance. So so if you're adding or replacing an existing unit with a CE marked machine that does not significantly affect the operation of the assembly, then no action is required. So, if you're replacing this, one robot with an exact replica, there's no need to have to re-CE mark. If you're adding or replacing an existing unit with a CE marked machine that significantly affects the safe operation of the line, then you would have to re-CE mark the machine, the assembly as a whole. And finally, if adding a partly completed machine, then you would have to CE mark or UKCA mark the machine as a whole. So a diagram of that really would be addition of a partly completed machine. Then you'd have to do a new CE marking process. If the addition was a complete machine, no new hazards, any increase of risk, no. So there's no new process. But if there were new hazards and the existing safeguards were not sufficient, then you'd have to again go through the CE marking process. Now, I'll touch briefly on 13849, which is functional safety of the control system. So there's really two parts for functional safety. There's the process world, and then there's the machine world. So process would be like oil refineries. And typically you have EN 61508, which is functional safety of electronic, programmable electronic safety related systems. And they're normally covered under SIL. But that can be, there's a standard that comes from that umbrella standard, which is 62061. And that's used for electrical and electronic technologies. And then there used to be 954, which was safety related parts of control systems, which has now been superseded by 13849. And the difference of that is that that's used for all technologies, not just for electrical, but it can be used for hydraulic and pneumatic. And so a lot of machine manufacturers will use that because it will cover those disciplines as well. So 13849 looks at performance levels, and they range from A to E, and they're in a hierarchy. So performance level E provides greater risk reduction than performance level D, and as mentioned, it applies to all sources of energy. It comes in two parts. So part one is the design, and then 13849 part 2 is really the validation. So how you would carry out function tests and fault simulation, testing of the safety related software and the hardware functions, and the check of sensors and actuators, after installation and wiring configuration. And there's a systematic approach to the design of the safety related control systems. I'm not going to run through everything, looking at the time. So we have our risk assessment using 12100. That would then take us on to our inherently safe design and safety specifications. So we'd then look to design the safety related parts of the control system. And for that, we'd use 13849 part 1. And once we've designed our system and we've installed it, commissioned it, we would then use EN 13849 part 2 to do the validation and check the overall safety requirements. The process that we use for the safety related parts of the control system, you can see here. So we identify the safety functions to be performed by the safety related parts of the control system. So that might be stopping the machine, for instance. But we need to determine the required performance level. And we do that by using a risk graph. So similar to a risk assessment, really. So we'd start. We would then look at the severity of the injury, S1 being slight, so normally reversible injury, so a scratch, bruise, for instance. Or we have S2, which is serious, which is an irreversible injury, or death, which is typically irreversible. Once we've worked out the severity of the injury, we would then move on to the frequency or the exposure time. F1 being seldom, so less often, or the exposure time is less than once every 15 minutes, or an accumulation exposure is less than 1/20th of a shift period, or F2 is frequent to continuous, and or the exposure time is long, so it's more than once every 15 minutes, or the accumulated exposure is more than 1/20th of a shift period. excuse me, once we've carried that out, we then look at the possibility of avoidance. P1 being possible in certain specific conditions, and P2, it's scarcely impossible. From that, we would then have our performance level that's required. That would be what we use to choose the safety component required. But then we also have to look at the category that it falls under. And these range from B to 1, 2, 3, 4. Category B means that a safety function can be lost in the presence of a single fault, and it's realized by what we call a single channel. So it's just an input and output. Category 1 is as B, but less likely because we're going to use well-tried components. Category 2 is as per 1, but again, it's less likely because we're going to carry out periodic testing, but we still use well-tried principles. And again, it's still single channel. Category 3 is a single fault, ideally detected, won't cause loss of the safety function. The second fault can cause loss of the safety function. There is a redundant structure, so it's now dual channel, and well-tried principles. And category 4, which is the highest, neither a single nor accumulated faults can cause loss of the safety function. Single faults must be detected, and redundant structure and cross-checking, as well as well-tried principles. And again, it's dual channel. So for a machine manufacturer, an OEM, if you're doing your performance level and then you're looking at your categories, depending on what you came out with on your chart, the moving from C to D can be quite expensive because you'd have to go from single channel to dual channel architecture. And so some manufacturers may take a lean approach so that they can go and use a single channel approach because it reduces the overall cost of the machine to make them more competitive. So again, that's something that would be picked up during Pure as well. And finally, I'll just run through fault masking. So fault masking really occurs on volt-free interlocks that are wired in series. And so we have a safety relay. We have 3 guards, and you can see that these are the 2 contacts per guard. And so at the minute, the guards are closed, the safety control is enabled, and the machine can be operated. The operator open guards 1. You can see that this contact is open, but channel 2 is defective. It's remained closed. And it may be in a washdown zone or something like that. So over time, there's been water ingress, and that contact has just welded closed. The safety controller does its job. It switches off because it sees an open contact, and the machine is in a safe state at the moment. However, when they've closed guard 1, the machine hasn't started because it only saw 1 contact open. And so it may be that the operator's been there a few years or over a period of time, and they know that if they open guard 1, they have to then open guard 3, and that makes the machine start. But it only makes the machine start because it opens both contacts. And that tricks the safety relay into thinking now that it's got a healthy system. So they open that guard, that clears the fault within the safety relay that was created through the 1 switch not opening here. And they then close the door. And when guard 3 closes again, the failure in channel 2, the first guard, is now masked. That's not seen. The safety control is enabled, and the machine can now start. But over time, in this washdown environment, channel 2 is now failed. And what that means is the machine can now be started with a dysfunctional guard. So the machine's now running. If guard 1 is now opened, because the switch has effectively failed, both contacts are closed, the guard is open, but the machine will still run. And so this is what is meant by fault masking. And a frequently open guard is something that's open more than once, is opened within a week time scale. And within the technical standard 24119, it states that if it is a frequently open guard and you have more than 1, then you can only ever have 1 interlock wired back to the controller. So you're monitoring each gate independently. So that's pretty much ran through the presentation with regards to machinery safety, and that's quite a lot to take in. I'll just give a very, very quick overview with regards to PILTS. PILTS is a business with the headquarters in Germany. We were founded in 1948. We were originally a glass blowing workshop, but our founder created the world's first safety relay for e-stops, and we now have, I think it's 44 subsidiaries throughout the world, over 2,500 employees. We're still a family-run business. The children now run the business, Thomas and Susanna. We have a mixture of products. So there's 3 divisions to PILTS. So we have our sensors, our interlocks, we have our controllers for the safety relays, the HMIs, e-stops, and we also do software. But we also offer consulting, engineering and training. So we can carry out pure assessments, risk assessments, safety design, all on your behalf. If you are an end user and you need a UKCA mark, or you're having a machine that's built for you, we can act on your behalf to make sure that it is being built in accordance with UKCA or CE. And then we can also carry out workplace safety, such as plant assessments, lockout, tagout systems, like I say, pure assessments, etc. And then finally, we actually offer training. We start from introduction, so the basics of machinery safety, fundamental all the way to expert. And so it's possible to kind of design your own path, really. So you may want to spend a day or 2 days doing pure risk assessment, find out a bit more about safety design with 3849, for instance. And then depending on your qualifications and everything else, you can do full-blown CMSE, TUV certified courses. So that just leaves me to say thank you all for your time this evening. I hope you found it informative and worthwhile, and I'll hand over to Richard and others to let me know if there's any questions.
Sorry, John, do you want to take Jason through the questions? We seem to have lost Richard.
Yeah, certainly will. First of all, Jason, thank you very much for an excellent presentation. That was really, really interesting, very detailed as well. There has been some questions in the chat that I'd just like to ask you, please. We did have one individual wanting to know what OEM actually meant, but somebody kindly answered that for us with the original equipment manufacturer. There was a question that asked if a business still has old machinery installed and commissioned in the 1950s,
yep,
how is that machinery affected by current and changing directives and legislation?
Okay, so it's a common question that we get asked, really. So, you know, an end user may have a machine that they purchased in the 50s, 60s, 70s, 80s, and it was fit for purpose and met all the regulations back then. So it's okay now. And the short answer to that is no. You know, you have a legal responsibility to make sure that the machine is up to date with current technologies, but also you've got the risk assessment side as well. And so what was discussed at the end about the fault masking, for instance, if you're using a machine that was probably built in the 60s, it was probably got volt-free contacts, it's all single channel architecture. The products themselves would have probably reached the end of their mission time. And so, you know, it would need an upgrade. So you can't neglect your responsibilities just because of the age of the machine. I suppose a way of looking at that, another way would be, you know, you've got a 1920s car and you fit a brand new V6 engine to it, but don't upgrade anything else to the car, it's not going to stop, etc., etc. So
Yeah,
Hopefully
I
that
think,
makes sense. Hopefully that answers the question.
yeah, hopefully it does, because the individual does state it would cost a lot of money.
It
Obviously
does,
for
yeah,
upgrade that
it will,
equipment.
yeah. So my first thing would be, well, you need to risk assess it really. That would determine the hazards, etc. You would then have a look at the control systems that are used. You may have rocker switches that would have been used in the past, but again, are commonly not used now because they can be easily bypassed and defeated. If you've got a machine, it's going to cost you £300,000 to bring it up to modern standards, but it's going to cost you, £500,000 to buy a brand new machine. That's not the old reasonably practicable. That you'd have to do justifications for buying possibly a brand new machine there. But no, you can't. Just because it's old doesn't mean that it falls outside the regulations.
That's great. Thank you very much, Jason. And another question as well was what type of competency training is required for somebody to conduct internal pure assessments on machinery?
Well, the HSE purely just say you need to be competent. So you can look at the HSE website and it will give you their definition of competency, but that really is down to experience, your level of understanding with the regulations and the standards. What experience do you have with machinery, for instance, and safety in general? What disciplines do you have? So, if my discipline is electrical and I know electrics inside out, am I the right person to go and look at guarding, for instance? I would say no. So, it may be that there's 2 or 3 people that go out and have a look at the machine in general, in question, because then you've got different disciplines as well.
That's great. Thank you very much, Jason. There's no other questions within the chat. I don't know if anybody has got anything they would like to come and actually ask Jason about, just briefly. You can just unmute yourself if you would like to ask Jason anything before we finish.
John, I thought I asked a question about legislation.
Oh, did you? Sorry, have I missed that?
Yeah.
I think there was a slide on legislation, what was coming into force after, was it January 2022?
Yeah, what's the question? Sorry.
It was likely what legislative changes are likely to occur after leaving the EC.
Okay, yeah. So yeah, as it stood, as of January 2021, we should have had the UKCA marking process. And you effectively had a 12-month period. So you had until the end of this year as an OEM really to meet compliance with that. But that's now been extended for another 12 months. So if we were looking at a machine, now, we would recommend that you go down a UKCA process for the machine. Even though there's a 12 months extension, because it's here, so it's not going away. Unless you've got European operations, and that machine could potentially be moved to France, let's say in 3 years' time, then it may well be worth UKCA and CE marking it. Because if you were to just UKCA mark the machine now, and then you were to send it overseas to a sister operation in France in say 3 years' time, they'd have to CE mark it.
Jason, thank you very much for that.
Yeah.
I've just noticed on the chat there, Lisa's put a comment on there. If anybody's looking for a role within health and safety, there's actually a link there. There's 2 jobs going at the moment. So if anybody would like to ask Lisa anything about that, please get in touch with her. Or if you can spread that information to anybody else that you might be thinking of a change. So please do that. But thank you very much, Jason. I don't know if there's any more questions, but we're 2 minutes over our time at the moment. But I would, on behalf of the North Wales branch, I'd just like to thank you for very professional, interesting presentation. There was a question in the chat there that did ask, would we be able to share your slides? I don't know if you're able to do that, Jason, if we can have them maybe in PDF.
Oh, yeah, okay. Well, yeah, it's a big file, but I can share them to
You did send them
yourself,
to me,
John.
yeah, you
Paul,
sent
yeah,
them,
you could.
yeah, you sent them to me, I think, Jason. So I have
Yeah,
got
but
them,
I've amended them, Paul.
Okay, great. Well, I mean, if you can send
yeah.
us a copy, then what we'll do is I was just going to mention to everyone on the call that we're going to send out a branch survey, a meeting survey. So if you can complete that, and then within that, you'll find there's a link to the website where you'll be able to see a copy of the recording and a copy of those presentation slides from Jason and stuff.
Yeah, I'll send you the link after this, because I've modified the slide deck to what it was previously.
Thanks so much.
That's brilliant. Thank you very much. Well, thank you very much, everybody, as well, for attending. Have what's left of the evening. Have a good evening and stay safe. Thank you very much, everybody. Good night.
Thank you, everybody. Take care. Bye-bye.
Bye.